Hello students, in the previous videos we have learned about some of the basic ideas regarding the electricity. Now we are moving to the electrical part. This is what the only topic left out in your syllabus. More generally, the power is defined as the rate of doing work or work done by time. So what is meant by work done by time? How much work has been done in a given time is called power. The electrical energy also defined in the same way. Electrical power, which is equal to amount of electrical energy consumed per time. Where the electrical energy is consumed and where the heat has been generated. So electrical energy is consumed or heat generated means whenever the current flows through the circuit, it will generate a heat or it consumes some energy in order to move the electron from one place to another place. So whenever the electron flows, it will generate a heat and it is dissipated as it means. So electrical energy consumed or heat generated, as we have studied, H is equal to I squared RT in the previous classes, heating effect of electric current. So electrical power means, from this definition we can write electrical power, which is equal to amount of electrical energy consumed by time. So electrical energy consumed can be replaced by H and T can be replaced by time. So electrical power is H by T. We know that H is equal to I squared RT. Now replace the H value in this equation. You'll get TT will get cancel each other. I squared RT you'll get. So P, which is equal to I squared RT. This is what the first equation you'll get. While you're applying Ohm's law, this you'll get two different equations for the power. So we know that what is the Ohm's law, which is V is equal to IR. In other words, I is equal to V by R. Replace I value in this equation, P, which is equal to V by R the whole squared into R. So the square is common for voltage and resistance. V squared by R squared into R. R squared and R will get cancel each other. P, which is equal to V squared by R. For our convenience, I'm just writing the V squared into V squared in the form of V into V. Again, you have to apply Ohm's law. In either of the V, we can replace Ohm's law. So V is equal to IR. So instead of one V, I'm replacing this V into IR. R get cancel each other. P, which is equal to IR. This is the more general form of electrical power. This is the expression which we are using to calculate electrical power. Sometimes we can use this also. P, which is equal to I square also can be, I square RT also can be used. So from this definition, what we can conclude, the power in any electrical circuit is directly proportional to I. When you are removing the proportionality constant, P will be equal to V into I. This is the expression you will get. The amount of power consumed in a device is directly proportional to the current flowing in the device. This is what the definition from this we are getting. So next is the SI unit of electrical power. So SI unit of electrical power is watt, termed as watt, and it can be represented as the letter W. So it can be defined as the 1 watt of power is consumed when 1 ampere of current flows at a potential difference of 1 volt. So if you are replacing from this equation, P, which is equal to VI. So if you are taking the potential as 1 voltage and current as 1 ampere, you'll get the power consumed is defined as 1 watt. More generally, the powers can be represented in kilowatts, because watt is a very smaller unit. For that purpose, we are using kilowatt. Kilowatt is the domestical purpose. General purpose, we are using a kilowatt. So 1 kilowatt is known as 1000 watts. So what is that? Next is the electrical energy. Electrical energy is the from the previous equation, power that is equal to h by t. From this equation, where it is, from this expression, we can write the electrical energy, which is equal to power into time. The unit of electrical energy, how much energy has been consumed by that circuit, can be calculated. The electrical energy means power into time. From the previous expression we are writing power, which is equal to h by t, means if you are transposing the t to the right hand side, you'll get electrical energy is power into time. So unit of electrical energy, that is h is equal to, what is the unit of power? Power is watt and time is measured in hours. So unit of electrical energy is a watt hour. The practical unit or the commercial unit of electrical energy is a kilowatt hour or 1 unit. If you are seeing your electricity bill, means that is the power consumption. The electrical energy consumption is represented in the form of unit, either it may be of 100 units or 1000 units, like that. So more generally we are using the term as 1 unit to represent the energy consumption. So how we can practically imagine it? So if you are having a 100-watt bulb at your home, so how much energy has been consumed by that bulb, means if we can have the expression like h is equal to p into t. Replace that. If the bulb is glowing for 10 hours, means what is the watt of the power? What is the power of that bulb? It is 100 watt, and you can replace that. How much time duration it is glowing? It is 10 hour. 10 hour means the energy consumed is 1000 watt hour or 1 kilowatt hour. This is what the energy consumed that bulb. So 1 unit also can be represented in the form of kilowatt hour. So what is that? 1 kilowatt means that I can write it as 1000 watts, and hour means it can be represented in terms of seconds. When you multiply this, you'll get 3.6 into 10 power 6 watt second, or 3.6 into 10 power 6 joules. So this is what the simple calculation of electrical energy consumption. By using this relation, you can calculate for some other appliances in your home. That's all.